Hello everybody, this is Dr. Thunder. Today, I would like to show you how to solve a US high school physics competition question. So we have a pendulum that is made with a string and a bucket full of water. So when the string is vertical, the bottom of the bucket is near the ground. The pendulum is set swinging with a small amplitude and a very small hole is open at the bottom of the bucket, which leaks water at a constant rate. After a few full swings, which of the following best shows the amount of water that has landed on the ground as a function of position? So we have 5 choices, A, B, C, D, E. So we want to pick the right one. So as we can see here, based on our common sense, a pendulum will swing like that. It reached the maximum speed when the string is at a vertical position. And then at some moment, the pendulum will stop, so the speed will be 0. So from the center point here to the right or to the left, the speed will slow down until it stops. So it has a maximum speed here and then 0 speed here. And then there's transition from maximum speed to 0 speed. And then we know the amount of water deposit on the surface is inversely proportional to the speed along the horizontal direction. So we know because the speed is not constant, so the amount of water should not be constant. So we remove A. And then even at this position, even the speed is maximum, there's still some water that is deposited on the ground. So choice B is not right because it says it has no water at this center point. And then let's look at D and E. We know at the center or at the position where the string is at a vertical position, the speed is maximum. So that means the amount of water is minimum. So, but here in D or E, the amount of water reached maximum in the middle. So we exclude these 2 choices as well. So the only right answer is C. But this is a quick and dirty method. This is understandable if we only have 3 minutes per question in the F equal MA test. Now we try to show you how to prove it in a more strict way. So let's replot the pendulum here. So we assume the length of the string is L, mass of the pendulum is M, and then the highest position of pendulum we assume is here with the angle theta 0. And then so at this position, the pendulum has potential energy but no kinetic energy. And at this position, the pendulum only has kinetic energy but no potential energy. So the total energy of the pendulum will be mgl minus L cosine theta 0. It's easy to figure out. So the length from here to here is L cosine theta 0. So the difference is L minus L cosine theta 0. So that's the total energy of the pendulum. Now we randomly pick a position X here, and then with angle theta. So we draw a coordinate x-axis. Here is the origin 0. So assume the speed here is v. Then its horizontal component is vx. So we have kinetic energy plus potential energy equal to the total energy. As we know, Vx is equal to V cosine theta. So we plug this here. So we have this formula. So we expand this, expand that as well. So we remove MGL from both sides, and we remove M from all terms, and then we multiply 2 cosine square theta to all terms. So we get Vx squared equal to this term. Because sine theta here is x over L, so cosine theta become this. So we plug this cosine theta into here, and then we get this term. It looks pretty complex, but now we assume G is 10, and we assume L is 1 meter, and then theta 0 is 60 degrees. So cosine theta 0 is half. And then we plug this value here, and then we know that x should be less than L, or x less than 1. Actually, x should be less than square root 3 over 2, but to make it simple, we assume x less than 1. So we have this term. And then because we know the amount of water is inversely proportional to Vx, so which is this term. So it's not difficult to plot the whole thing here, the amount of water versus x. So it will looks like that. We can use Excel to plot this, or we can just pick a few points and then plot. Like we can pick x equal to 0, and then a few more points, and then we calculate. Then we can get this curve. So this curve looks very similar to curve C. So this way we prove the answer in a more strict way. Thank you for viewing. If you like my tutorial, please comment, like, and subscribe.